Hello everyone and welcome back to Nunley Math. Thank you so much for taking the time to be with us today. We really do appreciate you being a part of this program. As always, I'm your host Aaron Nunley. I'm excited to have you with us as we begin to talk a little bit more about integers. In our last lesson, or last video, we talked about this idea of integers being positive and negative whole numbers. And we talked about this notion that when you have a positive number, it's like you're moving in one direction. And when you have a negative number, it's like you're moving in another direction. And then we talked about how that relates to absolute value and distance from zero. Today we're going to speak specifically about how to add integers. We're going to speak to this as though you are somebody who has already done this before. So please don't consider this to be a comprehensive introduction to all that is adding integers, but rather consider it to be a review of some concepts you might have heard before. If you're somebody who has struggled with integers in the past, I think I've got a couple tips for you that might help you to wrap your mind around it a little more easily. Now, it's not going to be a long video today. Hopefully we'll get this done in under 10 minutes or so, but we've got a couple real important ideas we need to make sure we point out. By the way, I will go ahead and tell you that operations with integers are one of the three things that students tend to struggle with the most. But when they get to Algebra 1, it's not so much the algebra concepts as it is keeping track of what happens with our negative signs. So even though you might feel fairly confident with this, it is probably worth your time to go ahead and watch the video just to make sure you have a really good handle on how integers work. Now, what I'm going to do is I'm going to start with some fairly simple examples like 5 plus 3. Now, most of you should be able to do that with pretty straightforward elementary school arithmetic, but I want to use this simple example to allow us to think about how numbers work on a number line. When we deal with addition, we need to think of addition as combining two things. That's the definition of addition. It's putting two things together. And when we think of these numbers, I want you to think of these as movements or motion on a number line. So that if I have a number 5, it's like I've moved 5 spaces on a number line. And if I have a movement of 3, it's like I move 3 spaces on a number line. Notice that I always start off at 0. I do my first motion, and from the end of that I do my second motion. I'm combining 2 slides to the right on my number line. Notice where I end up. I'm at the number 8. That should make sense to you all the way back in elementary school because you're used to doing 5 plus 3 with lots and lots of different things. It could be 5 marbles plus 3 marbles is 8 marbles. $5 plus $3 is $8. In any of those examples, all of them can be modeled or thought of as moving along the real number system farther to the right. I move to the right 5, I move to the right 3, and I just look to see where I end up, which in this case is 8. Now, even though it's a simple example, I like it because it helps us when we begin to think of other examples. So let me give you one more that's fairly simple, and then we'll talk about how this can help us. 2 plus 9, you hopefully already know the answer to that, but I want you to think of it in terms of slides on a number line. If I go 2, I'm moving 2 spaces to the right. If I go 9, I go from the end of that 2 and go 9 more. And where does that put me? Where do I end up? Of course, I end up at 11. Again, the number line allows us to model addition in a lot of different forms. I'm going to make it a little harder now. Negative 4 plus negative 2. Negative 4 plus negative 2. You'll remember in our last video on integers and absolute value, we said that when we have positive movements on our number line, or as we go farther and farther to the right, we get greater values. Positive numbers always move to the right. Negative numbers move the same distance, but in the opposite direction. So I can look at this number line and say negative 4 is starting at 0 and moving 4 places in the negative direction. And just like before, I'm going to combine that with a move of 2 in the negative direction. Where did I end up? I ended up at negative 6. Tell you what, I'm going to give you one more example of this, then we're going to talk about it together. Negative 5 plus negative 5. If I think of this as movements on a number line, I move 5 in the negative direction, and I move 5 more in the negative direction, and I end up at -10. I want you to look at these 4 examples together. Notice my examples are misnumbered. Don't let that throw you off. It really is just a typo. I'll fix that later. Notice 5 plus 3 equals 8, 2 plus 9 equals 11. We're really good at this. But notice what happens with negatives. -4 and -2 is equal to 6. 5 and 5 is equal to 10. When you have a negative number added to a negative number, it acts exactly the same way it does when you add two positive numbers together. You just add them like they were positive and realize you were moving in the negative direction. You add them like they were positive, and then you use the negative to give you the direction. In fact, when we give rules for adding integers with like signs, all we do is we add the numbers and we keep the sign. If we ever get stuck, we go back and think about what's happening on our number line. -5 and -5. I go 5 to the left and 5 more to the left. I've moved 10 to the left. Most students feel pretty good with this. Where they struggle is if I start moving in different directions. A -5 plus a 3. I get a lot of different answers for this, but let's just think about what it means for a second. If I move -5, I'm saying starting at 0, I move 5 spaces in a negative direction. If I do a +3, I'm saying from the end of my first arrow, I go 3 spaces in the other direction. Where does that put me? I'm at -2. Is that what you guessed? Hopefully it made sense to you. We're just combining the two movements. -5, +3, I end up at -2. How about this one? I move 2 in the negative direction, and I move 9 in the other direction, and where do I end up? I end up at 7. How about this one? -4 and +2. I'd strongly recommend that you pause the video, you try this one on your own for just a second, and see if you can do this without my help, then restart the video to see if it's making sense. If you feel pretty confident, you can just go ahead and skip and see if the answer you think is right actually is. I move 4 in a negative direction, and I move 2 in a positive direction, and where do I end up? -2. Last chance to do this on your own. I'd recommend pausing the video and trying it. It is a good idea to at least practice showing it on the number line, even if you do have a rule that you memorized, just because it gives you a better conceptual understanding of how numbers work. This says go 5 in a negative direction, go 8 in a positive direction. Where do you end up? At +3. Now, if I were struggling to do these and I was a student in class or in pre-algebra right now, I would make sure that the first thing I did on my paper was drew myself a number line so that I could draw arrows for myself along the way. Your number line doesn't have to be perfect and precise. It's more about being able to visualize whether you're going the same directions or opposite directions. Remember, when the signs of the number are the same, then you're going to go in the same direction, like on the previous slide. Backwards 5, backwards 3, forward 5, forward 3. But when you have different signs, you're moving in different directions. When you have different signs, you're moving in different directions. What does that do in terms of our computation? I want you to think about this for just a second. I happen to know that 5 minus 3 is 2. Notice 5, 3, and 2. I happen to notice here that 9 minus 2 is a 7. Notice if I'm ignoring the signs and I subtract, I notice that 4 minus 2 is 2. 4, 2, 2. And I notice that 8 minus 5 is a 3. Think about this. If I didn't know how to do these how to do this with a number line. I can look here and say, well, I know there are 5 and a 3, and they're going in opposite directions. The difference between those movements is a difference of 2. If I go 5 in one direction and 3 in the other direction, the only place I've actually moved is 2. If I go 9 in one direction and 2 in the other, there's 2, there's 9. The actual movement is only 7. These two parts of the movement undo each other. Same thing here. If I go 4 in a negative direction and come back 2, it's like I've only moved 2. It's the difference between the two numbers. If I go one direction 5 and the other direction 8, it's like this part of the number line is undoing itself. The only thing that matters is the difference between the slides, which in this case happens to be 3. It's a quick little memory device to allow you to calculate this quickly. When I see numbers that have different signs, I just subtract them like they were positive, the big minus the small. And then the way I decide which sign to use, whether it's positive, or negative, is I just figure out which one was farther. I moved a long way in the negative direction and only came back a little. I must still be on the negative side. I moved a little in the negative but came back a lot in the positive. I must be on the positive side. I went negative a lot, positive a little, I'm still on the negative side. You see, we can create a rule that way. All we have to do is subtract the numbers and find what the difference in our movement was. And then we're going to use the sign from the number that was further from 0, or the one I went the most. So if I went farther in the negative direction, my answer will be negative. If I went farther in the positive direction, your number is going to be positive. Hopefully that was something useful for you. I do appreciate you taking the time to watch this. If you got something out of this, please make sure you leave us a comment in the comment section so we know you're watching and that this is making sense. If you have suggestions for another way to explain this or some suggestions as to how to make the videos better, we'd appreciate hearing from you as well. Make sure you hit that like button, make sure you turn on your notifications, ring that bell so that you'll always know when something new is happening here at Nunley Math. We wish you guys all the best. Take care of yourselves, all right? Bye-bye.